Welcome to the deep dive. Today we're getting into something really fascinating, saffron.
That incredible spice, yeah. So
Yeah,
vibrant, so expensive.
exactly. And because it's so valuable, well, how do you actually know what you're getting? What makes one batch better than another?
That's the million-dollar question, isn't it? And we're going to tackle it by looking at a really important document.
Right, we've got the Codex Standard CXS 351-2022. It's the international standard for dried floral parts, specifically saffron.
Yep, it lays out the rules, basically.
So our mission today is to kind of unpack this technical standard, see what it tells us about defining saffron quality, how they measure it, and, why these rules even matter.
Because even a seemingly dry standard like this can actually tell you a lot about the product itself. It's quite interesting when you dig in.
Okay, let's start digging. According to this standard, what actually is saffron, like botanically?
It's very precise. It comes from the flower Crocus Sativus L, specifically the dried
The
pistils.
pistils, okay.
Well, hang on. It's actually even more specific. It's the dried stigmas, which are the very top parts, along with a bit of the style they're attached to.
Ah, right. So the stigma, that's the kind of trumpet-shaped bit at the end, often three little branches.
Exactly. Often three, sometimes serrated at the top. And the style is the thin stalk connecting it down towards the rest of the flower. The standard says saffron is those dried stigmas plus the upper part of the style.
Got it. So it's not just any red thread from the flower. It has to be that specific part. Okay, that sets the baseline. How is it usually sold then? What forms does it take?
The standard calls these styles. The most common one is filaments. That's what most people picture, I think. Those dried stigmas with a bit of the yellowish style still attached.
The classic threads.
Right. Then you have cut filaments. Here, most of that style part has been removed, so it's mainly just the red stigma tips, kind of detached little pieces.
More concentrated red bits, less of the yellow stocky part.
Correct. And then, of course, there's powdered saffron, which is just the filaments ground up.
Okay, filaments, cut filaments, powder. Does the standard say one style is like inherently better quality?
Not really in terms of the potential grade. The quality rules apply across the board, although some might argue it's easier to spot adulteration in whole filaments. But technically, any style can achieve any grade if it meets the chemical and physical tests.
Makes sense. They also mention other styles are okay if they're labeled clearly.
Yeah, as long as they're distinct and you say what they are, the focus is really on the underlying quality, not just the look.
So let's get into that quality definition. How does the standard start defining what makes saffron good?
Well, first, the basics. Section 3.2.1, it says the odor, flavor, and color have to be characteristic of saffron. No weird smells, no off tastes, definitely no rancid or musty notes.
Standard stuff for food quality, really.
Pretty much. But it does acknowledge that, where it's grown the soil, the climate, geoclimatic factors can cause natural variations in that profile.
Terroir. Even for saffron. Interesting. So beyond just smelling and tasting right, how do they quantify quality? Put numbers on it.
Right, this is crucial. They use a classification system. It's based on objective measurements, chemical and physical tests. This gives us the grades.
Okay, what are the grades?
There's extra class, which is top tier, then grade 1 or class 1, then grade 2 or class 2, and finally grade 3 or class 3.
Extra I, 2, and 3. Got it.
And even if saffron isn't sold with a specific grade labeled, it still has to meet the minimum requirements for grade 3.
Okay, so grade 3 is the baseline. Let's dive into those measurements then. The chemical tests sound key. What do they measure?
They are fundamental. First up is moisture content. It's capped at 12.0% weight by weight WW for all grades.
12% max water. That sounds important for keeping it from spoiling, right? Dryness equals shelf life.
Absolutely. Keeps mold away, preserves the compounds. Then there's ash content. They measure total ash and also acid insoluble ash.
Ash, or like what's left after you burn it. What does that tell you?
Exactly. Total ash is the overall mineral content. But acid insoluble ash is a really good indicator of inorganic stuff that shouldn't be there. Think sand, soil, dirt particles.
Ah, okay. A cleanliness check against grit. Do the limits change by grade?
Total ash max is 10% for all grades on a dry basis. But for acid insoluble ash, the dirt indicator, yeah, it gets stricter. For extra grade 1 and grade 2, the maximum is 1.0%.
1%.
But for grade 3, it's allowed to be up to 1.5%. It's a small difference numerically, but it signifies a higher level of purity, less soil contamination in the top grades.
So even a 0.5% matters at this level. What other chemical tests are there?
There's one for soluble extract in cold water, basically how much stuff dissolves easily. Max 65% for all grades, dry basis.
Okay, and then we get to the big ones, right? The things that make saffron, well, saffron.
Yeah.
Taste, aroma, color.
Precisely. The standard measures the strength of these by measuring specific chemical compounds. For taste strength, it's a compound called picrocrosin.
Crocus, got it.
For aroma strength, it's saffronol.
Saffron.
And for that incredible coloring power, it's crocin.
Picrocrosin for taste, saffronol for aroma, crocin for color. And I assume the levels of these dictate the grade.
You got it. The minimum required levels for picrocrosin and especially crocin go up quite dramatically with the grade.
How dramatically?
Okay, so for picrocrosin, the taste compound, grade 3 needs a minimum value of 40, grade 2 needs 55, grade I needs 70, and extra class needs 80.
Wow, okay, so extra class needs double the minimum taste potential of grade 3. That's significant.
It really is. It shows you're paying for demonstrably more flavor potential.
What about saffronol, the aroma?
That one's interesting. For saffronol, the standard gives a range, minimum 20, maximum 50, and this range applies to all grades.
Huh, a maximum. Why would they cap the aroma compound? You'd think more is better.
It is curious, isn't it? The standard doesn't spell out the exact reason. Maybe extremely high levels could indicate something off in the processing, or maybe it throws the overall sensory balance out of whack. It suggests they're aiming for an optimal aroma profile, not just raw power.
An optimal window rather than just higher and higher. Okay, so what about crocin, the color?
This is where you see the biggest numerical jumps between grades. Crocin equals coloring strength. Minimum value for grade 3 is 120.
Okay, 120.
Grade 2 jumps to 170 minimum. Grade I needs at least 200. And extra class, minimum 230.
Whoa. 120 for grade 3 up to 230 for extra. That's nearly double. The coloring power difference must be really noticeable.
It should be. If you buy extra class, you're getting saffron that chemically has almost twice the minimum coloring potential of grade 3. That's a major differentiator defined by the standard.
Okay, so these chemical tests really form the backbone of the grading. What else does the standard look at? You mentioned physical characteristics too.
Yes, that's covered in Annex I, Table 2. This part is all about physical purity, basically, limiting stuff that shouldn't be in there.
Like bits and pieces, contaminants.
Exactly. It defines two main types. Extraneous matter is vegetative stuff from the saffron plant itself, but not the valuable stigma-style part. So like tiny bits of petal or leaf fragments, plant waste, essentially.
Okay, stuff from the right plant, but the wrong part.
Right. And then there's foreign matter. This is anything objectionable that's not from the saffron plant at all. Little stones, dust, hairs, things you definitely don't want.
Definitely not.
Yeah.
And I guess the limits for these also vary by grade?
Oh, yeah, big time. For extraneous matter, the plant waste extra class allows only 0.25% maximum.
0.25%.
Tiny. Whereas grade 3 allows up to 5%.
5%. That's 20 times more allowed plant debris in grade 3 compared to extra.
It's a huge difference. And for foreign matter, the non-plant stuff, the limits are even tighter. Max 0.1% for extra in grade 1. That goes up to 1.0% allowed for grade 3.
So higher grades mean significantly less junk, both plant-based and external. You're paying for that meticulous cleaning and sorting.
You absolutely are. The table also lists limits for other nasty things. Insect fragments, rodent filth, mold, dead insects, even excreta. For the top grades, the limit for many of these is essentially 0 or not applicable. Lower grades might have tiny maximum allowances, but it's all about ensuring safety and cleanliness.
It really paints a picture of quality control. It's not just about the saffron compounds, but also about what's not there.
Exactly. And beyond those tables, the standard makes a few other key points, like Section 4 says no food additives are permitted, period.
Good. Pure saffron only.
Yep. It also requires compliance with general codex limits for things like heavy metals, toxins, pesticide residues, standard food safety stuff.
Right, bringing it in line with broader regulations.
And it stresses hygiene during handling and prep, pointing to other relevant codex hygiene codes. So it's about the whole process, not just the final test results.
Okay, so we have the definition, the styles, the chemical potency tests, the physical purity tests, no additives, general safety compliance. How does this connect to the label I see in the store?
That's Section 8, labeling. It mandates the name dried saffron. It allows specifying the style filaments, cut filaments, powder, and crucially, if it meets the grade requirements, the label can state the grade or class, extra, I, or 3.
So that grade on the package should directly link back to these specific chemical and physical benchmarks we've just discussed.
That's the idea. It provides a standardized way to communicate quality, helping everyone from the farmer to, well, you, the person buying it, It cuts down on confusion and potential fraud in a market for a very expensive spice.
So pulling this all together, why should you, our listener, care about this Codex standard? What's the takeaway?
Well, I think it demystifies saffron quality, doesn't it? It shows it's not just subjective hype. There are measurable differences, especially in those key compounds like crocin for color and picrocin for taste.
Yeah, and it explains the price differences you often see. You're literally paying for higher concentrations of those desirable compounds and a higher degree of purity, less contamination.
Right. Understanding this helps you appreciate what goes into producing and certifying top quality saffron. It gives you a framework for judging value.
It shows there's a real science and a regulatory system working behind the scenes to ensure you get what you pay for, hopefully. This standard is like the rule book for genuine high-quality saffron.
It really is. It underlines the complexity behind even a single spice.
So this deep dive has shown us that saffron quality is precisely defined from the exact plant part, those dried stigmas and styles through sensory checks, and crucially through chemical measurements of taste, aroma, and especially coloring strength via picrocin, saffronol, and crocin, plus strict physical purity limits.
And all that gets codified into that classification system, extra I, 2, and 3. Understanding the standard really does illuminate the effort involved.
It absolutely does.
Yeah.
And, thinking about those chemicals again, crocin, picrocin, saffronol, and how critical their levels are for the final grade, it really makes you wonder, doesn't it?
Wonder about what?
Well, how much do the growing conditions themselves influence those levels? The specific soil, the amount of sun, the rainfall in that particular year, the exact moment they harvest, how carefully they dry it. Could these factors essentially set the potential grade of the saffron before it even gets near a testing lab?
That's a fascinating point. How much of the final quality is determined right there in the field by nature and the farmer's skill shaping those chemical fingerprints?
Exactly. Something to ponder next time you encounter that amazing spice. What journey did it take chemically to get to you?